In this video, you're going to review how to simplify instances where you have radical expressions in the denominator, and the process for doing that is known as rationalizing the denominator. Before we get started into that, though, let's do a couple of review problems. Start off by first simplifying the following radical. Well, to simplify this radical, I'm allowed to take the square root of this fraction and make it a fraction of square roots, and that's based off of rules that were reviewed earlier in this lesson. The square root of 64 is one you may recognize as being 8. However, the square root of 729 might be one that you don't know offhand what the square root is. So if I break it down further into the square root of 9 times the square root of 81, because 9 times 81 happens to be one of the factorizations of 729, makes it a little easier because the square root of 9 and the square root of 81 are more common, because the square root of 9 is 3, the square root of 81 is 9, and the square root of 64 is 8, and 3 times 9 on top is 27, so 27 over 8 would be a simplified form of this radical. Now try this one. What is the simplify the square root of 2 times the square root of 32? Well, the square root of 2 times the square root of 32, 2 is not a perfect square. 32 is not a perfect square, although you could probably factor out some perfect squares from it. I decided to do this one by simply realizing the fact that the square root of 2 times the square root of 32 is the same thing as the square root of 2 times 32. 2 times 32 is 64, and so this becomes the square root of 64, and as a result, this becomes 8. So there are different ways to handle these. However, what happens when we're trying to figure out things like this, 1 over the square root of 5? So before we move on to this, find out what 1 over the square root of 5 is on your calculator. Okay, so now of these choices I'm about to give you, which of them is equal to the same number that you got for 1 divided by the square root of 5? Well, we know this here, that the square root of 1 over the square root of 5 is approximately 0.4472, and it goes on. It's an irrational number. And you got the exact same thing whenever you did, or you should have, when you did square root of 5 over 5. So these two quantities are in fact equal to each other. But, how do we determine that to be true for sure? I mean, the calculator might be off. Maybe there's some decimal places that we don't see on the calculator that, make it look, that would be different. Well, let's verify this. I'm going to let x equal 1 over the square root of 5, and I'm going to let y equal square root of 5 over 5. So letting that happen, I'm going to square both of them. So if I square x squared, I would get this. And if I would square y squared, I would, of course, square the square root of 5 over 5. By distributing the squares over that division, I'd be squaring the numerator and the denominator separately, and it would be the same thing. When I square 1, I get 1. When I square the square root of 5, I get 5. So x squared becomes 1/5. Whenever I square the square root of 5 for the second one, that's still going to be 5. When I square 5, it's going to be 25. Now, 5 over 25 can be simplified because 5 over 25 is the same thing as 5 over 5 times 5, and since I have multiplications of 5 in both the numerator and the denominator, I would be able to cancel, and canceling on top would leave me with 1, so I would end up with 1/5 as well. So x squared and y squared are both equal to 1/5, which implies that x and y are both equal to each other, because we started with positive numbers, which means that these two numbers are in fact equal to each other. It's this form here that's known as a simplified form. For it to be truly simplified, there should be no radical of any kind in the denominator. So we do a process known as rationalizing the denominator. So if I want to take a number like 1 over the square root of 5 and write it in what we would know as a simplified form, I need to get rid of that square root symbol in the denominator. Now, oftentimes we're used to getting rid of square root symbols or any kind of root by squaring or cubing or whatever the case may be, depending on what the root is. However, if I square this fraction, I get 1/5, and 1/5 and this are not the same thing, because remember, 1/5 is 0.2, whereas 1 over the square root of 5 is about 0.447. They're not equal to each other. So squaring this is out of contention, so to speak. However, I still want to be able to do some form of squaring to get rid of the radical. So what I could also do is multiply this fraction by another fraction. And whatever this fraction is going to be, obviously, for me to get rid of the radical, I like the denominator of this fraction to equal the square root of 5, because if I take the square root of 5 times itself, I'm squaring a square root, and that would make the radical go away. However, this number, this fraction I'm going to be multiplying this to, should equal 1, because I don't want to change the value of this fraction. I just want to change the fact that I want a different number in the denominator that doesn't have a radical with it. So any number that's represented as a fraction and is equal to 1 should have a numerator equal to its denominator. So for that reason, I'm going to have a square root of 5 on top as well. So typically what I'm going to do is multiply by a value that's equal to 1 that has a radical on top and the same radical on bottom. And the radicals on the bottom should hopefully cancel. So when I do it for this here, I get the square root of 5 on top, because 1 times the square root of 5 is square root of 5. On the bottom, I'm going to have the square root of 5 times the square root of 5, which is the square root of 5 squared. And of course, that's going to give me 5. So I end up with square root of 5 over 5. Now you try the same thing for the following. Try to simplify 4 over the square root of 6. Well, if you want to rationalize the denominator on this, I'm going to multiply this fraction by the square root of 6 times the square root over the square root of 6. Because multiplying square root of 6 by itself is squaring a square root, which ultimately will make it cancel. So on top, I'm going to have 4 times the square root of 6. On the bottom, I'm going to have the square root of 6 squared. Now, the square root of 6 squared on the bottom does become a 6. Now, some students make the mistake of thinking that they're done here. Remember, whenever you're simplifying, you have to simplify completely. So, yes, the radical parts are all simplified. I have the smallest possible number underneath the square root symbol. I don't have any radical in the denominator. But the 4 on top and the 6 on bottom are both divisible by 2. And so I should divide both of them by 2 to get 2 square root 6 over 3. That is the simplified form of that fraction. Now, rationalizing the denominator also works for cube roots and any other roots too. The other thing that I have to do when I do this is be careful about how I would handle this. For instance, I want to get rid of this radical that's a cube root of 7, which means I need to get a perfect cube under here. Now 7 doesn't have any, is a prime number, so I'm going to want to multiply the bottom by the cube root of 7 squared, which means I want to do the same thing on top. Because 7 squared times 7 would give me 7 cubed, and 7 cubed, cube rooted, would cancel the power and the exponent out. And so when I do this, I would end up with 3 times the cube root of 7 squared over the cube root of 7 cubed. Now the cube root of 7 cubed, as you see here, becomes 7, and on top I have 3 times the cube root of 49. And that's where I would end up, and that's because there's nothing else I could simplify. So you try this now for your last problem, for doing it for 5 over the cube root of 4. Well, the cube root of 4 is not a perfect cube. However, if you know your perfect cubes, you know that 8 is a perfect cube. So this 4 is actually 2 squared. I mean, some students will try to do the same thing they did up here and multiply by the cube root of 4 over the cube root of, cube root of 4 squared over the cube root of 4 squared, which you can definitely do. It will still work. However, you'll deal with bigger numbers. Recognizing the fact that if I simply multiply this 4 by 2, I would get 8, and 8 is a perfect cube. So if I simply multiply by the cube root of 2 over the cube root of 2, I'm going to get to the same answer. I just won't have to do as much simplifying when I'm done. Because on top, I'm going to have 5 times the cube root of 2. On the bottom, I'm going to have the cube root of 8. And of course, the cube root of 8 is 2. So the final answer is 5 cube root of 2 over 2. If you have any questions with this, please make sure to reach out and ask your teacher. Until next time, have a good day.